Audio Jungle.
Hello everyone, welcome to the video lecture series of operating system. In today's session, we are continuing with the topic in input-output management and disk scheduling. Specifically, we are focusing on disk scheduling right now. Myself, Kunal Panchal, your instructor. So, in this particular session, we are going to discuss the another disk scheduling algorithm, which is nothing but SSTF, stands for shortest seek time first algorithm. So what is shortest seek time first? As we have discussed, what is seek time? A time required to reach to a particular track number, or say particular track. That time is nothing but seek time, that we have already understood in the disk scheduling algorithm session. Okay, so in this case we will give the priority to a particular request which is having shortest seek time. So that request will be served first by this algorithm. So let us discuss the working of SSTF in detail with the help of one example. So as you can see in the example, a disk contains 200 tracks, as I told you in the FCFS also, the same number of tracks we have, and request queue contains track number, same number of track number we have, like 176, 79, 34, 60, 92, 11, 41, 114 respectively. Fine. Now the current head position, current head means current read-write head position is 50. That is given. Okay, 200 total, 200 tracks we have. The current read-write head position is 50, and these many number of track request we have in a queue. Okay. Now we need to calculate the total number of track movements by read-write heading by using SSTF disk scheduling algorithm. So let us discuss how we can execute the task of SSTF. Okay. In this particular example, so we need to start the journey definitely from the any current head position which is given to us as an input. In this particular case we have 50. 50 is the current head position. Okay, so we need to start the journey from 50. Now the next request in first come first serve, without bothering about any logic, just based on the arrival time we are scheduling the process for execution. But in this case, instead of arrival time, we need to focus on shortest seek time first. Means what? Shortest seek time we need to consider to schedule the process or place a request for execution. Okay, so 50. So we need to check current head position is 50, and these are the requested track numbers. So you need to calculate the distance between these between the current head position and these different track numbers that we have as an input, and the distance which is smallest, that request will be executed, or that request will be served first in this case. So you can see if you calculate the difference between 176 minus 50, the difference is larger definitely as compared to other track numbers. 79 minus 50, again it is larger. 34 minus 50, again it is larger. 60 minus 50, again it is larger, because we have one more process which is closest to this current head position. 92 minus 50, again it is larger. 11 minus 50, again it is larger, the distance. 41 minus 50 is the smallest one, you can see, because 114 minus 50, if you calculate, again it is larger. So the smallest distance, or this is shortest distance, is nothing but 50 minus 41, that is 9. So this 41 request will be picked first and it will be executed. So read write head will move from 50 to 41 first in this case. Okay. Now once it reaches to 41, again it will calculate the same, again it will execute the same logic. Whatever the remaining request we have, out of those requests, which one is smallest in terms of distance? So 41 minus, say for example 34, if you calculate, that difference is smallest as compared to other. So the next request will be fulfilled by the read write head position is nothing but 34. So it will move towards 34, and once it reaches to 34, again the same logic is applied for the next request. Fine. So again you need to calculate which request contains shortest distance as compared to the remaining request. So if you calculate 34, the current head position right now 34. So 34 minus 11, if you calculate, definitely it is shortest as compared to the other ones. So 11 will be picked for execution, and now the read write head position is located on the track number 11. Okay. Now what will happen in this case? Start. What will happen in this case? Once it reaches to 11 track number, now again it will follow the same logic to find out the shortest distance by comparing the remaining number of requests we have. So 176, then 79, then 60 we have, 92 we have, and 114 we have. These are the remaining requests we have. So out of these requests, which one is shortest? So if you subtract 11 minus say for example from the 60, definitely it is smallest as compared to other difference. 60, if you calculate 60 minus 11, definitely it is smallest in this case. Okay, so 60 minus 11 will be considered. Then the next request will be fulfilled by this algorithm is what? Again the same logic is applied. When it reaches read write head is located at 60 track number. Then which one is shortest? Definitely the 79 is shortest. So 79 minus 60, you can calculate the shortest one. So 79 will be fulfilled next. Then the next request is nothing but 92 we have. So 92 minus, you can 92 minus 79 is again a smallest distance as compared to others. Fine. Once we reach to 92, again the same logic is applied. Which one is smallest? 114 in terms of distance. So 114 will be executed first. Okay, now read write head position is located at track number 114. Now we need to have only one request in a queue. So 176 will be fulfilled at the last. Okay, so in this way shortest seek time first algorithm works. Now let us discuss the advantages and disadvantages of this SSTF algorithm. But before going to discuss the pros and cons of this algorithm, we need to calculate the total track movement by SSTF by having this set of inputs. So total track movements by the read write head is, in this case you can easily calculate 50. Starting we have started the journey from 50. So 50 minus 11. Okay, because you need to reach towards the last point to a particular direction. Okay, so 50 minus 11 plus Again, we have started the journey from 11 to 176. So 176 minus 11. So that, if you calculate the final value is nothing but 204. So 204 track movements are there by using SSTF with the help of these many track numbers. Okay. So let us discuss advantages first. So the performance is good due to less number of track movements compared to FCFS. So definitely the number of track movements is drastically reduced as compared to FCFS in the case of SSTF. So definitely the performance wise this algorithm works best. It means it gives optimal result. But there is one problem with the help of SSTF. It suffers from starvation. Why? Because in this case, the processor, or we can say the processor is partial. Why? Because we are not focusing on the arrival time to schedule the process for execution or to satisfy the request. We are not considering the arrival time. If a particular request is arrived and out of all the requests, if that request is senior most request and you will have give the chance to that process to execute the task at the nth moment. Okay, definitely starvation is present in this case. Fine, because there is an injustice as far as senior most processes are concerned. Whenever there is a biasing in terms of processor, definitely starvation is present. So one main big advantage we can say the performance is very good. Okay, because it has very less number of track movements as compared to FCFS and other scheduling algorithm. But the thing is it suffers from starvation. Okay. So I hope one more difference you need to keep these things in your mind. That could be considered as one disadvantage of this algorithm, which is nothing but overhead. Overhead is increased. Why? Why we can consider this overhead in this case? So you can see the working of this algorithm is at a particular moment of time. Once the algorithm is satisfying one request, again that algorithm needs to execute the same logic for each and every track number that it wants to travel. So at each and every, we need to find out the shortest distance, and according to the shortest distance, we are giving the chance to the particular request for execution. So definitely at each and every moment we need to the calculation is required. Fine. So definitely the overhead is increased in this case. Fine. So this is all about SSTF scheduling algorithm. I hope it was clear to you. Thanks for watching this video. See you in the next one.